Welcome to December 12th LeetCode Challenge. Maximum product of two elements in array. Given an array of integers nums, choose two different indices I and j of that array. Return the maximum value of nums at index I minus 1 times nums at index j minus 1. So we're basically trying to find the maximum numbers of two elements in the array by minusing the one index of it. So say if we're given the array of integer nums here containing 3, 4, 5, and 2, we want to find the values that will give us the maximum product of two elements. That are different indices from index 0. So for instance, if you were to pick indices of the values of the largest value 4 and 5, we minus 1 from each, so it becomes 3 and 4. 3 times 4 is equal to 2. Similarly, here we have two values of number 5. If we were to take 5 here and 5 here, minus 1 from both of them, because index I and j minus 1 each, and multiply, so then we have 4 times 4, which is 16. If we only have two values in the, for example, 3 here, we have 3 and 7, and we take 3 minus 1, which is 2, and we take 7 minus 1, which is 6, so it'll be 2 times 6, which is 12. Constraints are that the length of nums between 2 to 500, and each number index I, or j, I should say, is between 1 to 10 to the 3. So intuitively, given all the candidates here are non-negative, we hopefully have non-negative numbers, assuming, yep, right here, given the constraints. If you want to maximize the products of x and y, or these two values here, you would choose the largest values x and y. So for instance, in an array, we want to find the two largest value. That would be 5 and 5, for example, the 2 here. This is in this problem, we could just basically subtract 1 from our number before multiplying them. However, it doesn't change the logic of the two largest numbers, since every element can be reduced by the same amount. It will still be a non-negative number. Thus, for optimal, that's the reason why, because even if you do minus 1, it will never be a non-negative number. Thus, it is optimal for us to choose the two largest element, and in order to do that, we just sort the array and easily find the two largest element. And ideally, we would just be sorting it. So the first thing we want to do is sort. So we do array sort, and we're going to sort the nums array. And after that, we're going to find the integer x, which is going to be nums at index, nums.length. So that's going to be the largest element, minus, that's actually going to be the last element of the array, which is going to be the largest element. And then we're going to also define y, which is going to be nums at dot length, and this is going to be the second largest element in the array. Ideally, you can put this all in one line too. We can actually do this pretty. Then we want to return this right here, which is basically going to be x minus 1 times y minus 1. And we don't even have to define a variable either. We can just do it directly and put x into there, y into there, and erase this entire thing here. Probably the other way is probably easier to read, but let's see if this works. Submit. So we see that time complexity wise, we do have a sorting algorithm here. Nice, accepted. So this so if we were to sort the nums, the sorting array, I guess in Java would be big O of n log n times complexity. Space complexity is also similar. Actually not similar. In Java it is log n for a sort algorithm. So we have the memory complexity of big O of log n. For sort in Java. So that's pretty much it. Have a great day, everyone.